introduction. So who can tell me what the definition of a population is? A group of, think of what's before it in your orders of organization. Group of species living together, whoops, in a given area at a specific time.
Members of what?
Whoops, I did it again. And again. Yeah. So we are going to calculate populations in this unit. And there's a lot of different ways to look at how you calculate populations. Because people look at it differently, depending on what they're really trying to calculate. So give me a simple way to calculate the population of this class. Counting. We're going to count. How many people? What's another way? No.
Oh wait,
Have somebody count for you.
Category, how we are dispersed. Like, you could say by gender, but in this case, how many are boys, how many are girls. It's really not dispersion, but dispersion, how we're laid out. You see how people are here. So yes, we can calculate race and gender, but that's not population. The population is all the species. So we make up one population. What's another way to calculate? What happens if I tell you, all of you, we're going to only use this side of the room? How does that change the population?
We all gotta move to that side.
You got to move to that side. What happens? You lose what?
Space.
Space. So what's that word I'm looking for? If you reduce space, but you count the same amount of people, nobody knows? It involves area. Good, it's density. All right, so by definition, if we're calculating population size, it's the number of organisms in a given area. We calculate size, it's the number of organisms in a given area. And if you look at this graph, this map of the U.S., you see that Florida is highly populated. But let's look at other areas like Texas. You see how it's dark green. There's a lot of people, right? So if I go to density, it changes. It's no longer in the darkest group. Why? Think about it. Because there's a lot of space. There's a lot of people in Texas, but Texas is a large state. You know, people that live in Texas, they have land. So they're spread out. Versus us, we're still up there. And look at New York. New York is so small and all the high rises. So the population density of New York is extremely high. Their population is high too. But that's the difference when you calculate. You're looking at space or the amount of people per unit area. And then dispersion is how organisms are arranged. And that's not really relative to humans because humans aren't really dispersed in certain ways. But when you look at other organisms, who can explain these types of arrangements? Look at the pictures. I'll go back. Let's finish. Who can explain?
I guess the elephants live in different pods.
Pods, that's true. They're clumped. What else? What can you tell me about the second picture?
Spread. Like
Spread
everywhere.
how?
Like it's everywhere.
How? Spread out how? Because the elephants are spread out.
Like cream
But they're literally everywhere.
Look at the difference between picture 2, picture 1, picture 3. How are they spread?
They're tight together, but they're everywhere.
But how? You're almost there. When you look at this, it looks what?
Shrubs.
Evenly distributed. That's the second one. And what's the third one?
Unevenly distributed.
Okay, which means what?
Scattered.
Scattered, random. There's no order. So which one do you think is the best for survival? Clumped. They work together in groups. They have a better chance of survival. They have a better chance of defending themselves. They share their food because they guide each other. So clumped is the best. And there's many different ways to calculate a growing population. A lot. It depends on what you're looking to calculate. But when you're going to calculate change in a population or growth rate, okay, what are you going to add or subtract or incorporate into the formula? How do I calculate population change in this class? Birth minus death. In this class, it would be coming into the class versus leaving, which is a whole other way to calculate. Does anybody know at what rate the U.S. population is growing?
A fast one.
A fast one. What's a good mathematical name for fast?
Rapid.
Rapid. What else?
Quick.
Even quicker, like so quick
Super
that
solid.
it doubles each time. What's that called?
Exponentially.
Good.
Wow.
We're growing exponentially. And then, when we look at how to calculate, there's going to be these factors that affect growth. And we're going to talk about all that during this chapter. Okay, carrying capacity. Tell me where you've seen that word, carrying capacity.
Oh, water.
Excuse me,
Water.
what about it? Think of, you see this word all the time.
Like in elevators?
Elevators, what does it mean?
Oh, like
How much they
can
be.
How much can be held
Wait up, your computer's gonna.
based on, wait, I have to plug in. So if I'm talking about population and carrying capacity is linked to populations, what do you think is the key word? The maximum amount of what? Humans or organisms in an area that can be what? Fill it in for me. Maximum amount of species in an ecosystem that can be what? Held by what? By what? What's the factor that we have to take into consideration? In an elevator, it's
To
weight.
be able to live.
Good. What helps you live?
Resources.
Resources. Good. The maximum amount supported indefinitely by its environment. Tony, there's a lot of graphs, okay? It's a lot of graphs and interpretation of graphs, which is a great skill because you have to be able to interpret graphs. This K right here, that's what carrying capacity stands for, okay? If we're going to say the maximum amount supported in a given area, you always have to remember that for humans, we have many different factors that determine our carrying capacity. Water, food, space, all those. K stands for carrying capacity. So whatever, let's say for example, in this population, what's happening in the green curve? Look, interpret this curve for me.
It goes up and down.
The population explodes or booms, it exceeds the carrying capacity, which means it exceeded what?
The resources.
The resources. And when you don't have enough resources,
Depleted.
you start to what? Deplete. I mean, what happens to the population?
It starts to die out.
It starts to die out. And in this green curve, if I tell you, interpret this curve for me, you're going to say the population explodes, exceeds the carrying capacity, and then the population declines all the way. There was no recovery. What happens in the purple?
It goes up and it's stable.
Good. That's exactly what that is. It goes up, it meets the maximum amount of resources, but it stops growing, so population continues to thrive. It stays stable.